To better work with sums, it's important to know algebra rules for finite sums. We have 3 different rules. Your author in the textbook actually writes these down as 4 different rules, but I've always thought writing the sum and difference rule down as 2 separate rules is silly because, of course, addition and subtraction are the same thing, right? Because when you're subtracting, you're just adding a negative. So if I have a sum that has a formula that has a plus or minus in it that I could think of as a first formula plus a second formula, I can add those 2 sums respectively. And I thought we'd just look at an example to try and confirm that that makes sense. So let's take the sum from k equals 1 to 3 of k squared plus k. And what I want to do first is just write out this sum exactly as it is. I'm going to plug 1 in and get a first term, 2 in for a second term, and 3 in for a third term, and then find a number. So when k is 1, I get 1 and 1 make 2. When k is 2, I get 4 and 2 make 6. And when k is equal to 3, I get 9 and 3 make 12. 12, 18, that sum is 20. So now what I want to do is apply this rule where I split it up into 2 sums. And if I get the same number, then I will have a pretty good understanding of this rule. So I'm rewriting it using that first algebra rule for the sum. So now I have these 2 different sums to write down. So what I think I'll do is just write out the first sum, where I add up the first 3 squares. And then the second sum, I'll write down where I just add together the first 3 positive whole numbers. 1 plus 4 plus 9, and then in my second summation, I would have 1 plus 2 plus 3. So let's see if we can add those together. Let's see, if I add those together, I'll get 14. If I add those together, I get 6. 14 and 6 make 20, and I get that same value in both calculations. And if I really think about it, all I'm doing is using the associative and commutative properties of arithmetic to rearrange these sums, because if I take 1 and 1, I get 2, 4 and 2 make 6, 9 and 3 make 12. All right, so the sum and difference rule seems to work. My next algebra rule for finite sums is the constant multiple rule, which says if I have a formula that has a constant multiplied to it, I can factor the constant out. That's just the distributive rule of multiplication over addition. You can factor out that constant. The constant rule says if I add a constant to itself n times, I get n times that constant. And that rule is often forgotten by students later on, but it's actually kind of silly. So let's just look at a pretty easy example. Let's say I add 1/3 to itself 3 times. When k is equal to 1, I get the constant 1/3. When k is equal to 2, I get the constant 1/3. And when k is equal to 3, I also get that constant 1/3. 1/3 plus 1/3 plus 1/3 is 3/3. Well, that's n times 1/3. And so the constant rule seems to work as well.